Okay, so back for another question. We'll see how this one goes. I pulled out the plug, so hopefully you'll have that feedback now. So hopefully you can hear me. Also turned up the volume a little bit. I'm not sure. Or excuse me. What did I do? What did I do with the volume? I turned up the volume a little bit. Yeah, I turned up the volume a little bit. Hopefully you can hear me a little bit better. Okay, so let's get to the problem. See how quickly we can do this. Binary vertical order traversal. Given the root of a binary tree, return the vertical order traversal of its nodes from top to bottom, column by column. Two nodes are in the same row and column. The order should be from left to right. So 3, 9, 20, 15, 7. Oh, excuse me, 9, 3, 5. Oh. Whoa. 9, 3, 15, 27. So I understand the left to right row traversal. However, vertical traversal, that's really unusual to me. I don't know what this is supposed to look like, man. I don't know, how do you determine which columns are in the, or which row, yeah, which columns are in this, which nodes are in the same column? How do you even decide that? Excuse me. So 4 is on its own, 9 is on its own, 3, 0, and 1 are all in the same column. No kidding. 8 is on its own and 7 is on its own. I guess if you go to the left, that's considered, -1 column, and if you go to the right, that's considered +1 column. Interesting. I don't know. I guess we could figure out, we can go all the way to the bottom left, all the way to the bottom right, and figure out, which columns, and then dump everything into a vector. I think we're probably better off just using an unordered set of vectors, and then just dumping that into a vectors unordered map, a hash map. But I guess we'll do it that way. If it's a left or a right, number of nodes, 0 to 100. Really interesting. Actually, if we know how many nodes there are, then we can just no, never mind. We'll just do left and right. Let's see how we do. Let's see how we do with this. There's probably a better way to do this too, but we're gonna do it this way. So we have a result. We have a depth first search. We'll say I guess column, int, and tree node R, say otherwise we'll say R, we'll say result of column dot pushback R value, and then f of R left and column -1 f on the right side, column +1, Oh, you know what? Actually, uh-oh. Uh-oh. Mm-hmm. Gotta figure this one out. Maybe we can do this. Whoops. Let's say x equals standard min of x in column. And we're gonna say standard vector of vector ret is going to be smallest value for column. I mean, you can do this too and make it easy. Well, no. It's got to be the size, I think, of result. Right? Same size. And these are just empty vectors. And then, or even just the size, right? And then we say for auto p of result, we're going to say ret of p dot first plus x equals p dot second. Something like this. Something like this. I don't really know. Output expected. Nice. Nice. Oh, probably because we didn't DFS anything. Tree node R, we'll do root. Column starts off at 0. That might have something to do with it. Runtime error, nice. Overflowed. Really? Why would this overflow? Why would that happen? Excuse me? What? Thought I was done with this already. Thought this was gonna be super quick. But there we go. 3/9/2015/7. Okay. Type properly. One, two, three, four, 5. 0, 1, 2, 3, 4. Huh. Maybe my math is wrong on this, which it probably is. Four. 0, 1, 2, 3, 4. Should be 5, not 4. Why is this 4? Yeah, okay. Zero, -2? How did that happen? What? Oh, that's probably why. It's a 0. It's actually minus x, not plus x, because x is a negative number. It's my mistake. There we go. Okay, I was thinking about it, like, what did I? Pretty sure I did it right, but no, slightly off my reasoning here. So what we're trying to do is basically we just subtract 1 if we're going to the left, add 1 if we're going to the right, put that all into a hash map, and then we're going to shift everything into an array at the end. And then so taking this extra number to figure out how far did we go to the left, and then when we shift everything, put everything back into the array, actually it's a negative number, so you subtract that amount to make it go further to the right, further to 0. Let's see, does this work on empty trees? Seems to work on empty trees. What about this? What happens when we do these things? Invalid test case root must consist of some values from -100 to All right, that's pretty good. Let's give it a shot. Oh, really? No kidding. What's wrong? I thought it was so clever too. Expected 8.2 and I had 2.8. What is this one? This. Oh, you gotta be kidding me. That's upsetting. I thought I was so smart. Ah, really? Okay, we said, what was my result? Hold on. Okay. 4, 9, 5. Yeah, okay. I think it's got to be a breadth first search rather than a depth first search because yeah, we get the 2 before we see the 8. That's pretty wild. That's interesting. No kidding. So you can't do this with a depth first search because that's so annoying because the depth first search goes left to right and you actually go under the. That's crazy. Brother. Come on, man. Alright, we'll do a breadth first search then. That's crazy. That's crazy. So what is this first value? Yeah, we'll push the root. Yeah. It's a level order, right? So we have two while loops. Not Q is empty. We have similarly not Q empty. Standard Q. New Q. And we'll say int or tree node which equals Q dot pop. We don't need to use ints, right? I can use just tree nodes. Pointers are fine. That's wild, man. That's really funny. You can't. That's really annoying. Well, I mean, you can't really be empty, can you? It's not R. Just throw that in there. So x equals standard min of x column. Oh, we would push a column in there too, wouldn't we? Well, in this case, the column is no. Interesting. Could use a tuple then. Pair of a node and a column, right? Yeah, I'll do tuple. Which node and a column, right? Something like this. That's fine. That's fine. I don't know if we could do this. We could try it. Okay, so yeah, when you pop this, you pop this has a column with it already. Result column push back R value or which we do R. I prefer that root. So we'll say not R, and then you Q or new Q push back make tuple of the R left column plus minus 1 and then R right column plus 1, right? And then you set this Q equal to new Q. Okay. And that should be enough if you do that. You have a similar kind of a thing going on. So, yeah. Let's try that. See what happens here. Oh, no kidding. Really? Okay. Interesting. Does this work? One, two. What does that do? Okay, we get, no, it works. That actually works. That's kind of surprising. So where do we run into our error here? Left is -1, right is +1. I actually don't think we should run into problems here at all. Let's just see if we get that far. Again, not really expecting this to take this long, but I must have done something silly. 3, 9, 3, and there's 9 and 8. Pop the root, our value, pop, min x column, result column pushback our value should be 3. Alright, 0, 3, pushback or make tuple left and right. And the left is 9, the right is 8. And where do we run into problems? We get 9. We try to push back what 9 is on. 9, 8, 4, 0. What is the problem? What? Why is there an issue? Why is there runtime error? What's going on? Excuse me. So we get to R value 3, and then qpomp just doesn't work? Does this not, does this also pop the Q? Is that what happens? Am I unfamiliar with how this works? Oh, you know what? I think it's because these can't be references. I think that's why. Yeah, I think so. It's pretty interesting. Let me just see. Queue size is 1. Question mark, question mark, question mark. Push back. So yeah, this is null sometimes. Okay, interesting. So that's why you can't use references, because when you pop that portion of the queue, it disappears. Disappears. Interesting. A copy of a pointer is fine, I think. Oh, we get the right answer too now. There you go. So breadth first search. Okay. Let's try the other examples now. Pretty interesting. Pretty interesting problem, interesting solution. Let's see if we got it right now. There's a good chance I missed something. Yeah, okay, there we go. Alright, that took a while. How long did that take? Almost 25 minutes, 30 minutes. Man, I technically failed that one, got that one wrong. That's so annoying. It's really annoying. Kind of wondering why I can't use references. Not wondering, but thinking. You could actually just put the popping at the end, because they're doing level order. So you could actually use a reference and just put the pop at the bottom. Let me try that. And it's time for bed. Ooh, TLE. Wait, what? Huh? Wait a minute, excuse me? No, that's interesting. Okay. That's very interesting. I was not expecting that. If you take the front. Oh. Can you do pop? That's why. Still need to pop in the. That's why. Interesting. Yeah. Yeah, so you just have to remember to pop under both. Yeah, it's like a very subtle thing. So if you use a reference here and then you try to pop immediately, you've just popped the reference. So it does something really funky. But if you use copies of the pointers and the integers, now in this case the data is not too bad to copy, because it's just an integer and just a pointer. Really shouldn't be too bad to copy. However, in a situation where you don't want to copy those things, you might want to be able to use references, and then you want to pop appropriately. However, if you have null pointers being thrown in there, then you got to be careful if you don't pop the null pointer, right? Because that's what was happening. This is going down a different branch. You need to make sure you pop in all the branches. Very interesting. Very interesting. I like this solution. It's not too bad. This is yeah. The reason you have to do the level order traversal for this is that the the program, like, actually in the depth first search can go underneath and you have the wrong order for the column, which is pretty funny. That's very funny. Yeah. I still kind of like using this unordered map to kind of build the result at the end. Yeah, technically you don't need to use this map. You can build this directly. The way you would do it is pretty much you need to know how far to the left you're going, and then use that as the negation of that as sort of the first value that you input here. It's a little more expensive, I think, in terms of time. But I guess you kind of save a little bit because you're not doing this at the end. Yeah, alternatively, just thinking if there's a better way to do that. I don't really think so. I mean, you could just, you know, from the problem description, you could just always, you know, go 0 to 100 for the size of the. Oh, that's not what I wanted. Go back. Could always go 0 to 100 for the size of the vector here, and just always kind of put everything in the middle. Well, no. You still need to. No. Let's actually try to do it the other way. So, yeah, let's try to do it the other way. Find bottom left node, leftmost node. While root or yeah, let's see. You basically say could do this too. Actually, this is wrong if you do this, because you can go to the right, to the left a whole bunch, and then go to the right even further. So yeah, this won't actually work. You need to, you basically need to traverse the whole tree. I actually prefer what I did initially. Take it back. It's not as easy as it looks. Take that back. Take back what I said. This is a challenge. Yeah, I actually prefer this. I'm thinking about it. You basically, the other option really is just to go like, you know, allocate this all in one shot. And then, I don't know, man, even then it's still like, how do you know? Yeah, I don't know. I actually prefer this way. I like this. There may be another way that's clever that I'm not thinking of, not realizing, but let's move on from there. It might be someone smart might have it in the discussion. Like how do you not just like throw everything into a hash map? because you kind of need to know how far to the left you're going and how far to the right you're going, which requires you to pretty much traverse the whole tree. Like you kind of need to go through the whole tree to figure that out, because just how the trees are structured, it can be really difficult to actually find how far to the left or how far to the right. You could traverse the tree once to find out, but the problem with that is like then you've traversed the whole tree. It's like, well, you're about to traverse the whole tree anyway, so you might as well kind of do this all in one shot. I was thinking maybe you could create like a linked list, but no, that's not really good either. That's not that great either. Yeah, linked list of your vectors, we'll say, of the values, and then dump the linked list into the vector at the end. But you might as well just use a hash map. Like, what's the point? Why bother? It might make it so much harder for yourself. Anyway, all right, pretty good. So thank you all for watching. I will talk to you soon. I think I'm gonna head to bed now. And yeah, we got Columbus Day tomorrow, so that should be good. Got some time off from work. Yeah, man, took a vacation. It's really nice. Taking some time off. Let's relax, solve problems online. Really enjoy doing this. I kind of take a lot of time doing this. I'll be perfectly blunt with truth be told. But I do like this. So yeah, I'll hit the bed soon, and tomorrow morning I'll probably get right back into this. So yeah, thanks again, and talk to you soon.